Hey, it's me Travis at Maxim Integrated Applications, and in this video I'll show you how to sense motion from 100 meters away using an I2C bus extended with OneWire. I'll show you how to combine the length benefits of OneWire, easy OneWire programming on a microcontroller, and a OneWire to I2C bridge so that you can measure almost any type of sensor from up to 100 meters away. For the demo later in this video, I'll be using the MAX32630FTHR microcontroller dev board along with its programmer, the DS28E17 OneWire to I2C bridge, an LSM9DS0 accelerometer breakout board, and some various cables and connectors. Before we get started, I've linked some useful videos in the description on how to extend I2C lines with the DS28E17 and on how to program the MAX32630FTHR. You can watch these to get familiar with the material that I won't be covering in this video. If you're not familiar with OneWire protocol, that's okay. Our Mbed OneWire library makes coding the DS28E17 easy, and once it's set up, you can treat it just like an I2C master. This library gives you support for all current OneWire masters, including the ones built into the MAX326XX series of low-power micros. It also defines classes for all the popular OneWire slaves, with functions for all their features. Let's look at the class for the DS28E17 OneWire to I2C bridge. These I2C style functions allow you to easily control the I2C bus without needing to sort through the OneWire protocol. Pretty neat, right? So now I'm going to show you a demo of all this working together to sense motion from up to 100 meters away. Here are the hardware connections. I have the MAX32630FTHR board connected to my PC along with the MAXREF-DES100 HDK programmer. From there, I route VDD, ground, and OneWire through 50 meters of Cat5e twisted pair cabling to the DS28E17 daughter board. From there, I route VDD, ground, and the I2C bus to the accelerometer breakout board. Now let's look at the demo firmware I wrote that is linked in the description. At that link, you'll find the simple program used in this demo, along with a debug version in case anything goes wrong. This program starts by including all the relevant libraries, defining some addresses for the accelerometer, and setting up the development board. It then runs through the setup routine for the OneWire master and slave. This is the trickiest section of code, so I'll explain each line in detail. First, we create a OneWire master object using a constructor for the specific master we're using. I'm using the one built into my microcontroller, so I use the MCU OWM constructor. Then we use the init function to set up the hardware master. Now we're ready to set up the OneWire slave. The first step is declaring a search state struct, which will hold the ROM ID of any OneWire slaves found on the bus. Next, we use the findFamily function to set what type of slave we're looking for. In this case, the family code of the DS28E17 is hex 19. Now we're ready to perform a OneWire search using the OWNext function, which finds a ROM ID and stores it in the search state struct. Next, we create a multi-drop ROM iterator, which is a base class for any OneWire slave. We'll pass this iterator to a DS28E17 object and then assign it the ROM ID we already found. Now the I2C bridge is all set up, and we can treat it just like an I2C master with functions like write data with stop. The rest of the code sets up the accelerometer, reads the data, and serial prints it in the Arduino serial plotter format. Now I'll upload the code and take you outside to show you the demo in action. So I've uploaded my code and have everything connected here outside. My friend Oliver is way over there at the end of the cable, holding the accelerometer. I'll have him do some jumping jacks so we can see the real-time data. Go for it! Wow, this is so cool. This graph is showing his motion from way over there. I should have set the accelerometer range larger to avoid hitting the limits, but you get the point. Okay, you can stop. And there you have it. Now you know how to measure any I2C sensor from up to 100 meters away using the DS28E17 bridge. You also know that the easiest way to do it is with a MAX326XX microcontroller with built-in OneWire master on an easy-to-program Mbed-compatible dev board. Don't let long distances stop you from using the sensors that you need in your project. That's it for now. See you later.